We go for the acidity of carboxylic acid, that is the next topic. It comes under properties of carboxylic acid itself. Now, carboxylic acid is a weak acid. As you know, acid is nothing but a compound which donates its proton. It's called as acid. So it is a weak acid compared with the other mineral acids. The mineral acids are nothing but the strong acids, which are nothing but HCl, H2SO4, HNO3, that is hydrochloric acid, sulfuric acid and nitric acid. So during ionization, our single bond COOH reacts with water. It produces carboxylate ion, that is our single bond COO minus, which have that is the carboxylic acid ion consists of a negative charge, along with that H plus, that is from the acid H is relieving as a H plus, that is proton. So the acid donates its proton and converted into carboxylate ion. If you compare with phenol, the carboxylic acid has 4 into 10 to the power of 7 pKa, and phenol has a 10 to the power of 7 pKa. That is, if it is reacts with sodium bicarbonate, this is called as sodium bicarbonate. Bicarbonate means HCO3, NaHCO3, that is called as sodium bicarbonate. It produces a corresponding salts. So the carboxylic acid is have a 4 is nothing but comes under acidic range, and 10 comes under alkali range, that is above neutral. So the carboxylic acid is more acidic compared with phenol. In presence of aqueous sodium bicarbonate, it results in a corresponding salt, that is sodium salt, along with a carbonic acid. It is nothing but a combination of water with carbon dioxide. Combinedly called as carbonic acid, and its pKa value is 4 into 10 to the power of 7. So next we go for the effect of substituents on acidity. The electronic effect of substituents decides the acidity of OH. So this is a continuation of acidity of carboxylic acid, effect of substituents on acidity. So the substituents which are having based on the electronic effect of substituents, the acidity of carboxylic acid is decided. So if it is attached with, that is the R, based on the R may be an electron withdrawing group or electron donating group. If R is an electron withdrawing group, the acidity will get increases. If electron withdrawing group is present as a R, then the acidity will get increases. If R is nothing but that is a group, or alkyl or aryl group, which consists of a electron donating substituents, then it decreases the acidity. So for example, I give some aliphatic acids with the electron donating groups. So R is nothing but a electron donating group. So I gave CH3 COOH. So what is the nature of CH3? The H is nothing but always H is having a property of relieving as a proton. So it always donates its electron to the carbon. So the electron density is more in this carbon, so it donates the electron to the COOH. So its pK value is 4.76. If you come for the alpha substitution of electron withdrawing group, keep in your mind electron withdrawing group. Here I gave electron withdrawing group as a Cl. So Cl have a electron withdrawing effect. So this C is having a electron density which is given by the H's will be attracted towards the Cl, so the acidity will get increases. That is 7 is a neutral, below is acid and above is alkali. So the acidic range comes down. So I gave, this is a functional group. a carbon which is connected with the functional group is called as alpha carbon. So the alpha substitution will occurs. So the alpha carbon consists of a first substitution, that is Cl. So the acidity will get increased. Acidity increased means the acidic range will comes down, that is 4 to 1 or 0.1, that is increasing acidity. Okay, so 2.86 which have a more acidic value, and along with the second example is alpha carbon which have a 2Cl, the acid ranges comes down, that is acidity will get increases. Acidity will get increases if it has a 1Cl 2.86, if it has a 2Cls it comes to 1.48, if it comes to a 3 chlorine, 3 electron withdrawing group is there, then automatically it is a highly acid compound, and it is as pK value is 0.7, pK value is 0.7. Then we go for the beta substitutions. In that, beta substitution means this is the alpha carbon and this is a beta carbon, that is functional group next carbon is alpha and another one, that is alternative one is beta. So if it has a electron withdrawing group, it acidic range will get comes down to 4.05. If you compare with alpha and beta substitution has less acidic compare with alpha substitutions. Okay, then we go for a gamma substitution, that is a third carbon from the functional group which has a more value, that is 4.50, which has a less acidic than beta and alpha.